Explanation of case study. On August 2024, a continuous heavy rain triggered the collapse of a retaining wall at Taman Bunga Raya, Jalan Genting Kelang, Kuala Lumpur. The Kuala Lumpur Fire and Rescue Department (JBPM) found that a landslide had occurred on the hillside, thus also causing the retaining wall failure. The impact of wall falling caused the houses to shake and causing injuries. The mode of failure that aligns with the case is sliding. Based on study case, student can conclude the pressure diagram. Considering the soil is waterlogged and was assumed as a single layer, both soil pressure and water pressure acted on the retaining wall. The diagram has three triangles: the active earth pressure, water pressure, and thus both create a bigger triangle labeled as total pressure. Next would be the factors contributing to failure. The first factor is changes in groundwater table. Rainwater collected on the retaining wall back soil. The water fills the pore spaces in the soil, causing it to be saturated. Then, the pressure within, also known as pore water pressure, will increase the horizontal total stress. Thus, this will create a high hydrostatic pressure that makes the retaining wall slides away from the soil. The second factor that contributes to failure would be reduced foundation in soil strength. The soil types might be non-cohesive and moist, thus the friction between soil and the wall is weak. Therefore, active pressure is higher than wall resistance. This can cause the retaining wall to slide or overturn. Here is the proposed design for the retaining wall, which includes several key elements to ensure stability and drainage efficiency. First, student added weeping holes, which are small straws built into the wall. These allow water behind the wall to escape, preventing water buildup that can increase pressure. Next, students increase the thickness and height of the wall. Thicker, taller wall can resist greater active earth pressure. Other than that, students also included a concrete base at the bottom of the retaining wall. This acts like a strong foundation. It prevents the wall from sliding. Behind the wall, we place drainage aggregates. These are cross materials like gravel that can help water flow freely aside from reducing hydrostatic pressure. Lastly, the French drain below the structure. This drain collects and redirects groundwater away from the wall, keeping the soil from becoming waterlogged. Together, these elements create a stable, well-drained retaining wall that can withstand both soil and water pressure.